Hello everyone, I'm Paul and today we're solving problem 2187, replace non-coprime numbers in array. This is hard and this might seem very tricky, but actually it's not that difficult. So next I will show you how to solve this step by step. We are given an array nums such as this one, and we need to repeat this operation until it's impossible. And the operation goes as follows. We need to find any two adjacent numbers that are non-coprime. And in case you know what coprime is, down here we have the definition. Two values are coprime if the greatest common divisor of these two values is exactly 1. What this means is two values are coprime if the only common factor among these two values is number 1. So for each operation, we need to find any two adjacent numbers that are non-coprime, and we need to replace them with the least common multiple of these two numbers. We need to repeat this operation until it's impossible, then we stop the process and we return the final array. Now here we need to calculate GCD, this is greatest common divisor, and LCM, least common multiple of numbers. In case you know how to do this, I will show you. Well, actually for this one, in this case, we will use a Python function. And the formula for this is number A times number B divided by GCD of A and B. So we are using a Python function to get this. And with this value, we can calculate LCM. So we need to find adjacent numbers that are non-coprime. For example, we can take 6 and 4, and the GCD of 6 and 4 is 2. And this is greater than 1. What this means is these two values are non-coprime. So we can merge this. So we need to get the LCM of these two numbers. So we do 6 times 4 divided by this, meaning 2. And this is 12. So now we can replace these two characters with number 12. So now this is the new array, and we will repeat this process until it's impossible, then we stop. And the final array that we can get is 12, 7, 6. Now the question is, how can we solve this? Because we need some sort of standard process. We need to know which pairs do we have to merge. And here is the key for the problem. It can be shown that replacing adjacent non-coprime numbers in any order will lead to the same result. This means we can try pairs from left to right, for example. And what this means is we can use a stack. This is initially an empty array, and here we are storing the result. We are trying every pair from left to right, and we are storing the result here. So the stack is initially empty. We are iterating this from left to right. First we are here, and given that this is empty, we add 6 to the stack. Next we are here, so we add 4 to the stack, and now we have one pair to test. So we know that the result for this GCD is greater than 1, so we need to merge these two elements. What this means is we can pop this and we can replace this with LCM of 6 times 4 divided by GCD of 6 and 4. And we know that the result for this is 12. So now our stack has only number 12. Next we are here, so we add 3 and we are doing the same. GCD of 12 and 3. This is 3. We know that 3 is greater than 1, so these numbers are non-coprime, so we can merge them. And LCM in this case is 12 times 3 divided by GCD, meaning 3. The result for this is 12. So we pop this and we replace this with number 12. Now we are here, so we add 2 and we have another pair to test. So GCD of 12 and 2 is 2. This is greater than 1, so these numbers are non-coprime. So now we need to merge this. LCM in this case is 12 times 2 divided by 2, meaning 12. So we pop this and we keep 12 here. Next we are here, so we put 7 in the stack and now we are testing this pair. And GCD of 12 and 7, this is 1. So this is a coprime pair. And what this means is we can't merge these two numbers. So we keep both numbers in the stack and we continue. Next we have number 6, so we add this to the stack and we do GCD of 7 and 6. The result for this is 1. This means that this pair is a coprime, so we can't merge this and we continue. Finally we are here, so we add 2 to the stack. We take these 2 elements and we are trying this pair. GCD, in this case 6 and 2. The result for this is 2. 2 is greater than 1, so this is non-coprime. And what this means is we can merge these 2 elements. So now we take LCM, and this is 6 times 2 divided by this. And the result is 6. So we can pop this and we replace this with this. So now we reached the end of the array and we can return the result, which is this array. So as you can see, this is pretty straightforward. The key is down here. And with this in mind, let's go with the code. First, the result is an empty array. And remember, this is our stack. And now we can iterate every number in nums. And first we add to our stack the current number. And now, while we have at least one pair to test, meaning the length of result is greater or equal to 2, number 1 and number 2 are result at -2, result at -1. Now the GCD for this pair is GCD and 1 and 2. And if G equals 1, we break. What this means is if we have a pair that's coprime, we break the loop. Else, we need to merge the last 2 elements in the stack. So we can pop the last one. And we can replace the second to last, meaning result at -1 right now, because we are using pop here. We are replacing this with n1 times n2 divided by g. Remember, this is the formula for LCM. And finally, we can return result. So this is it for the code. Let's submit this and see if it works. As you can see, this works and it's very efficient. Time complexity for this function is big O of log the minimum among n1 and n2. So overall time complexity is big O of n times log the maximum value in nums. And space complexity is big O of n. So this is it. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.